Hi everyone, welcome back. In this video, we will see relocation and protection in hardware. Guys, in the previous video, we have covered what are the various kind of performance issues of fixed partitioning memory management techniques. Right? Hope you understood it clearly. Okay. So here, if you look into this concept, this relocation term is you already heard in the concept of linker and the loader, right? So who is responsible for relocation? Loader. Loader is responsible for performing the relocation. Hope you remember it, right? So which means that when you are going to have some kind of main memory which is of some size, anyhow operating system is going to reside in the remaining memory area, like the remaining user area is going to be partitioned based on the fixed partitioning or variable partitioning. Now in this particular partitioning, some process might be loaded at some location like P1 at this particular location. Now here various instructions are going to be existed, right? So these instructions need to be relocated. Am I right? Something like those instructions might be relocated to 100k plus 10, which we discussed already, right? Yes. So now after some time, some process P2 came for the execution, and suppose for example this was replaced with the P2 now. P2 now, right? So if I am going to execute now again the P1, suppose for example P1 has got the chance to place here, then what will be the its relocated absolute address, right? That might be something like 200k plus 10, which you might not know, but we are guessing something like this, which means that earlier it is like 100k plus 10, now it has modified to 200k plus 10, right? So now what will happen to the loader? Loader will get confused, whether I have to go with 100k plus 10 or 200k plus 10, right? So in general we have to have some kind of generalized solution, guys, right? So what is that? Instead of loading or instead of using the load time binding, we can use simply runtime binding. What is the meaning of runtime binding? I am going to directly get absolute address, right? Guys, to make it clear understanding about this particular video, just go ahead with the earlier videos of linker and the loader, so that you can get this video more understanding, right? So if you are going to make directly using the runtime binding instead of having the load time binding, our problem is going to be solved, right? So what is the meaning of runtime binding? I no need to convert any kind of a relocatable address to absolute address, right? I can directly use absolute address as it is, guys, right? So which means that when a particular address which is generated by the CPU, I can directly map it to the memory. Is it happens? Yes. Right? The memory contains what? Absolute address, right? The actual location where I want to go, right? So if I am able to do like that, that will be the better option, right? So for example, if it is CPU here, generally here I coined one terminology called physical address. Absolute address I can call it as physical address, right? So when a particular CPU generates an address, I can call it as a relocatable address or logical address. That will be taken care by some particular memory manager, which itself try to convert into absolute address. I can call it as physical address, right? Why it is physical address? It is referring to the actual location of the physical memory, You can call it as a physical address. Now, what will happen in this particular thing? Right? So the memory manager will perform the relocation as well as the protection. How it will done? Right? So once the address which is generated by the CPU, I can call it as a logical address. This logical address will be taken care by the limit register. There will be a limit register which will check for the address generated is less than or equal to the limit register. If it is satisfying the condition, I will go for adding that value with the, I can written like this, relocation register. Right? What is relocation register here? Relocation register means the place where you loaded the program. The place where you loaded the program. Do you know the really where the process might be loaded? We don't know. It will be known at the runtime only, right? Something like it might be 100k or it might be 200k or whatever it might be. That will be added here when the limit register is going to be satisfied, right? So here guys, what is the purpose of limit register here? Right? Limit register purpose is to achieve the protection mechanism. Right? Try to observe. If I say this is the main memory where operating system will reside, and suppose for example this address is 0 to 100, this address is 100 to 200, this address is 200 to 300, like that. For example, our process might load in the location 201 to 300k. Then what will be the relocation address? Relocation register contains 201k. And in this particular point, what will be the number? What will be the label address? Label address something like 1 or 2 or 3, might be anything. Right? We hope you understand, right? For example, I want to move to 200k place or 201k place, some 3. This is the thing, right? So then this is what a relocation address. Relocation address that was generated. Now what will happen? Here CPU generated the 3. That 3 is going to be compared with this thing. Right? Which means that which is always going to check with what is its range. What is its range? Its range will be from something like 0 to 99. 0 to 99. If its range is something like 0 to 99, then it is going to check. If it is satisfied, I will be added. Right? So something like if I am going to have 3, right? The range might be, limit range register range might be anything between the starting to ending. Starting to ending, right? If the given logical address might not fall in this particular range, definitely that will lead to access any one of the area other than this thing. Other than this area, it might fall into any other area. Then that particular situation I can call it as trap. Right? So trap means what? The intention of you will be the area where you want to require, but it will lead to another memory access, which we can call it as a trap. Fine. Right? So that is where it is going to perform. Right? So always your range should be between the start to end. I can call it as limit register. Based on this, I can achieve the concept of protection. Right? So this is the structure of relocation and protection in hardware. Right? Once this particular condition is satisfied, I will be added so that I can get the absolute address. No need of getting any kind of confusion. Guys, try to think, does this relocatable register, is it going to vary its values? Yes. This particular values is going to vary depending upon where you are loading the process. Right? Yes. And what about these things, limit register and the relocation register, where they will maintain? Does they maintain inside the process? No. they are going to be maintained in the operating system itself, right? Because those instruction or those values are going to be depend upon where they are loading. So based on that, I have to modify its values of limit register as well as relocation register, right? Which means that I can say the limit register and relocation registers are under the control of operating system. So in order to access these values, you have to have certain kind of privileged permissions. Is it true? Yes. Okay, fine. And one more important point, guys, do you think that this entire process is easy? You might think that this process is very easy, but in general, very easy means I can say this process is very slow, but in general it is a kind of huge process, because for every logical address which is generated here, I have to check with the limit register and I have to perform the addition, right? Which means it is not fast, right? So hope you understood how this relocation and production in hardware is going to be happen. I hope you understood this video clearly. Thank you.